Oh, look, the music just went down. So we're about to get started, everybody. Spread out, make yourselves comfortable. This is a very COVID-safe audience today. So welcome to the few of you that came. If you ask a question afterwards and you come down to booth 409, we'll give you something special. But here's the secret that I think you probably haven't heard, which is if you just come down to booth 409 and you say you came to this thing, we'll make sure you get something special. Because there's precious few of you, it's the last one of the day, and we're happy to do it. So I will say this, there really aren't very many of you, which is both a blessing and a curse, so we can be super interactive and I can answer any questions you have as we go along, okay? So don't be shy, ask away, let me know what you're thinking, tell me your thoughts on this, I'd be more than happy to answer them. So my name is Joel McKelvey, I'm with Sisu, and what I want to do is talk with you a little bit about the difference between what we do traditionally in analytics, what we can do with machine learning, what that unlocks for us, and how to put the power of machine learning in the hands of every analyst, which is very, very important. So one thing we do know is that most data goes unused in an enterprise. That probably doesn't come as much of a surprise to any of you, but it's truly the case. And there's reasons behind why it is hard to use data in the enterprise today. Business data is hard to use. It turns out the insights that we get from data come often too slowly. They're not terribly actionable, right? And they're not done against a complete data set. And so what business decision makers are getting from their data is often not a whole lot of great and useful stuff. And so only around half of decisions in businesses are actually made using data. And humans need good, actionable, fast data in order to make better business decisions. So let's talk about the complexity of the data that we're accessing today as a business. And over time, along this bottom axis, we're doing pretty well with human beings. Our existing approach is allowing smart analysts to access and use data relatively effectively. The problem is this, the data itself, and in particular the complexity, the dimensionality of the data is growing exponentially. Now as data people, it's no surprise that there are three V's of data, right? There's no surprise that the data is growing in complexity. But what is a surprise is that the tools we use to analyze that data have not been growing in their capacity to analyze this data at the same rate. So what does that lead us to? It leads us to this quote from Gartner, which is a very interesting and powerful quote. Essentially what we're saying is, human beings need assistance. Human beings cannot access and manually analyze data at a rate fast enough to impact the business today. And we see that in that metric of only half of decisions using data, 64% of data being used, right? We see the proof of this statement. Now, our founder and CEO, Peter Bayless, said it a bit differently, and that is that automation, in particular through machine learning, is required now to remove that human bottleneck. There's actually an interesting blog post on our site, and the discussion is about if you could hire enough analysts to keep up with the growth in complexity in data, that very soon analysts would be the largest organization in your business, and you'd be doing nothing but essentially analyzing data all day. So what gives? How do we solve that problem? Well, the answer is this concept called decision intelligence, which incorporates, as part of what it can do, most of what business intelligence can do, but goes beyond it. And it brings in modern technology to help deal with this complexity and this change in the underlying data that businesses are struggling with today. And we see also from Gartner that there's a strong growth in investment in decision intelligence going forward, which begs an excellent question, and that is, what is decision intelligence, right? And how is it different from business intelligence? And how is it different from what we're talking about when we're talking about AI ML? So decision intelligence is a combination of factors. It's using advanced technology, integrating with existing and powerful processes, and using a human as well to make better decisions. And unlike things like business intelligence, which are focused mostly on monitoring a metric and building a report or a dashboard, decision intelligence is focused on better decision making in the business And it seeks to solve that problem of how do I get the data I need to make the decision that I have to make to impact my business. So it behooves us then to think a little bit about how decision making is made in the business and elsewhere. So let's talk about the difference between analysts and machines and what they can do and what they're good at and what they're not great at. Because I think this is an important point, right? If you have a smart analyst team, you are able to mask this challenge of complexity and data better than if you don't. So you may not feel as much pain today. Human beings are great at dealing with a certain amount of complexity and being very intuitive and creative about how they deal with it, prioritization and only choosing to focus on those things that matter the most, and are really good at extrapolating with a relatively tight defined set of data. And it's no mistake that our phone numbers are a certain length, our emails are a certain length so that we can remember them. Human beings are good at that scale. Machines are good at a much, much larger scale. Yes, it's garbage in, garbage out. That is a known problem, but they scale much, much larger. So I would say the challenge we have in data today is as follows. It is taking cloud or machine scale data and putting it in front of human beings at human scale so that humans can make the decisions they need in order to better impact the business. Those types of decisions which humans are truly best at and best capable at doing. So we talk about how it impacts an analyst's team to think about the number of tests, the number of hypotheses, the amount of analysis that is required in order to deal with this complexity. And here's a quote from one of our customers about hypothesizing and executing against this huge complex data set. It's weeks or months or years. And it's simply not possible for a human being alone. And I think that's the takeaway. So let's talk about the decision-making process. In general, it consists of 3 big questions we ask of data. And down in front here, I know we'll know what all those 3 big ones are. But let's take it in sort of 3 steps. Normally, we see something occur, and we ask ourselves what happened. And this is a pretty typical thing that is answered by business intelligence. Business intelligence tells you your metric is at the following rate. If it's a good business intelligence tool, it will tell you this is what it was yesterday and the day before and the day before. Then you can, from that, make some determinations, and if you've got a smart analyst team, dig into the data and maybe come up with an answer. But really, the next question that comes after what happened is, why? And that's what you're paying your analysts to do. You're paying analysts to be smart and dig into and explore the data and identify the reasons why, the drivers behind metrics changing over time. Once you kind of know why, the next question is, what do I do about it? Right? And that is possibly the most important way to get actual value out of data is to take action against that data and then see a change in your business. There is an important cognitive thought here that you should keep in mind too, that it is fast that you are able to answer these, the faster you're able to answer these questions, the better you are able to take the action at the end and the better the outcome. Because the human process of question asking is extremely iterative. What happened? This happened. Why did it happen? Because of this. Well, why did that happen? Let's ask that question again. Let's dig in. And the process of analysis is actually this digging in, this iterative process to try and come to the root cause or the root driver of change or the core of action that you need to take in order to influence the metric. And so it's really important not only that we ask what, why, and now what, but that we also are able to do it quickly and iteratively to dig in to find the kernel of truth. And so when we're talking about making better decisions in the business, this is the type of thing that we have to be able to do, and we have to be able to do it with speed in order to have impact. So where does AI ML, particularly ML, come into play in this? So if you look at this rather wordy chart, and I apologize, you'll see these 3 things in the middle, and these are really what, why, and sort of now what that I talked about before. But it's important that those things exist in a context where we know your data is complex and it's at scale. You have business logic that understands how your metrics operate and how they're defined. And once you've come to this idea of what to do next, you need to always know what's going to occur with those metrics over time. You need some interface or user experience in order to continuously go in and work with those metrics. You need connections into all your other tools and systems. And really importantly, you need programmatic access, which is a really key way of taking action or operationalizing what you find from those three core types of analysis. So analysis on its own, just this ability to know what and why, and now what is going on with a metric, isn't enough. It has to be tied into a larger system. And so that larger system is super important for the context of analysis. So as you might imagine, as a person from Sisu, we're super excited because this is effectively what Sisu does. We can connect right into that Databricks Lakehouse data. We can also, and that gets us access to data at scale and complex data. And we also can connect into a centralized metric store, in particular dbt, where you might have defined your metrics. And we can import those in to Sisu for analysis. And then inside Sisu, we do a series of AI/ML-based analyses, and then you can consume them either in us or through a third-party tool or via API programmatically to drive action to make a difference as we go forward. So this is a nice long preamble. I promise in a few moments I'll show you how it works. How's that? So where do we exist in this world where traditional business intelligence is really showing you kind of what's up with your metric over time, and maybe data scientists are digging into or further exploring the data at scale to try and get to a certain place? Decision intelligence sits in that space between the two. It uses the technologies associated with data science to answer many of the questions that business intelligence cannot today. And it uses the tools of business intelligence to convey and operationalize the findings of data science. And so decision intelligence is all about making those better decisions by tying those two somewhat disparate disciplines together into a single operational and functional whole. Okay, we'll start with that. Questions and thoughts. I tried to go pretty quickly through that. All right, so that was fun, but let's stop talking about theory here and let me do a quick demonstration of how this works. Bear with me, live demos on real data, so be cautious. All right, anybody know what this is here? It's a dashboard. Anybody seen one of these before? Yes, everyone's seen a dashboard. It is the front door of every analytics tool and really important, maybe not terribly exciting, but very, very important as a way to convey and collaborate around a metric change. This particular dashboard is describing revenue for a weekly business review over time. Anything interesting about this big blue chart in the middle here about revenue that we can see today? Kind of going down, right? So that's not good if you're interested in higher revenue. So in a traditional business intelligence tool, what do you do here? You're going to explore this data, right? And in Sisu, you can certainly do that as well. I'm going to show you here, so bear with me. Again, live data. Let's hope the network is working. So this is an exploration of that chart. There it is. All right, so same chart. Now I can do data exploration. As you might expect from any tool, let's say I'm going to pivot by an aspect of revenue, maybe by a user loyalty program, and we will see whether or not user loyalty program is what's related to our decline in revenue. Okay, well, that's a little bit of a messy chart, sorry. So let me choose this one. I prefer a stack chart for this. All right, can anybody tell here whether or not user loyalty program is contributing to our decline in revenue over time? Maybe. You might look at that and you might say, okay, what's the light blue one? Looks like that silver loyalty program. And it does seem to be declining week over week. All right, so let's assume that silver loyalty program is in fact the reason for our decline. How long did that take us to do? I don't know, 15, 20 seconds? It's not terribly long, and I kind of knew what I was going to click on ahead of time, right? So how many things do you think in a relatively simple data set, like the one that we have here, might contribute to that metric change? How many times do we have to run that 20-second pivot? Well, let me show you what the magic of Sisu really is. So instead of exploring from here on this same chart, I just do this. What drove this change? I click on it. You saw it just kicked off an investigation. It's going to take a few minutes depending on how the network is doing, so I apologize. This is always the fun, risky part because I apologize. There are no smoke and mirrors here. This is actually taking place here. Okay, so it's working. So what have we done here? Let me call your attention first and foremost to these little numbers right up here in the corner. Not maybe the most exciting thing, but what Sisu has just done under the covers using machine learning is performed that same hypothesis test that you might see to determine whether or not something is causing or is the key driver of that metric change. In this particular case, we have about 24 dimensions of data, several 100,000 rows, and by breaking apart the data into all its groups and subgroups, we tested 2.4 billion hypotheses in the seconds that I just ran there. So it took us 20 seconds to run one hypothesis that we think we might have determined some type of relation to metric change from. We just ran it 2.4 billion additional times in the same 20 seconds. We identified 1,000-ish facts that actually have a bearing on the metrics changing. Here they are stacked in order of their impact against the metric. So what did we find? It does look like user loyalty program is having an impact on metric change, but it might not be the thing that's contributing the greatest to metric change over time. That is actually users with a gender of M, and you can see that we have determined that this group consists of 1.7% fewer rows than it did the previous week, but that the actual value in revenue went down 3.1%. So it's contributing $15.4 thousand to the decrease in revenue over time. This is certainly something we should look at. So what have we done in that 20 seconds? We've seen something happening. We've asked what. We've asked why, and it's given a list of why. And now what we have is some idea of where to start doing some type of an action. So one of the things that Sisu does that's super interesting is it also looks at subgroups ranked underneath the current group. So if you look at males that have been purchasing, and you look at the subgroups under them, Sisu is going to tell you what's contributing the greatest in a combination subgroup of men who are in user loyalty program silver. And they actually contributed a significant amount to the decline in revenue. Also, those that are ordering through digital wholesale channel and ages 26 to 29 and 32 to 50. And also those that are ordering three components. So what action do we take? We know we need to take action with male, silver loyalty program in these age brackets. And now we have an idea of what to do next. So in a few seconds, we've gone from 2.4 billion possible causes, 2.4 billion hypotheses to test, to a listing of what has the greatest impact and an idea of what action to take as a business. Now, Sisu goes a little bit further than that as well. We do some helpful interpretation of what's going on in data for presentation. Here's a smart waterfall chart that's talking about those things which are contributing to increases in revenue and those which are contributing to decreases in revenue. And you can add and remove dimensions here as you report out. But this gives you a really good idea of what action to take, how to report on this action, all in a few seconds. So this is what it takes to take large data sets, large complex data sets, and operationalize insights from them. We can find them quickly using the power of machines. We can interpret them quickly using the power of machines. And we can put them right where they are needed in order to have impact on the business, all using the power of machine learning, and that is what Sisu does under the covers. Now, there's a couple of other interesting things that I think are pretty cool that we might want to go through. And let me see if I can find that for you. So in addition to just having a chart which is kind of like revenues going down, as we saw in that second chart we were exploring with user loyalty program, it's kind of hard to tell sometimes whether or not it's a statistically significant decline or increase in something. So here's a different data set around churn trends for a video provider. And you can see that churn actually was going down over time, up for a while, and then is going down again. This is a machine learning generated trend analysis of the data set. So we can not just tell you, well, your metric is out of some sort of set parameters. We can tell you that there's been a trend, how long that trend has been going on for. And interestingly enough, not unlike the chart before, I can initiate an analysis that compares those two trends one to the other to give you an idea of the difference between those two groups in your data and what is driving the difference between those two groups in your data. Is it running and everything? I apologize, I can't really see here. Give us a second. Ooh, what time is it? 5 minutes till the, oh, it worked. Okay, great, fine. So in this case, we did an analysis of what, 2.3 million hypotheses. We found 5 things that are really contributing to the change. And you can see on this chart, this is sort of the first trend and how it went up and down over time. This is the second trend, how it went up and down over time. And you can see that churn is down 12.6% between those two groups. So now we've been able to automatically identify a what has happened. Even when it might not be totally clear that there is a trend, we can use the math to identify the trends. And then once again, we know what has happened because we've seen the trends. We can compare the trends and figure out why they are different. And then from this, we can dig in, which looks like there's 3 types of promotional code that this organization was running. 1 is contributing to a decline in churn, 2 are contributing to an increase in churn. It is recommended that probably we start offering promos to those over the age of 55, and that we figure out what's going on with the promo for customers between 26 and 40 that are using this promo code. So again, super fast and super capable of doing this analysis. Yeah, so we have a question. Thank you, by the way. It's a little lonely up here. Yeah.
Talk a little about what's happening behind the scenes when you click that, like what models are running or like what exactly it's doing.
Sure. So we are running, well, it depends on which one you're asking about. Are you asking about our churn detection algorithms or? Yeah, so I don't actually know the answer on the naming of the churn detection algorithm. So that might be something to come down to our stand, 409, and ask more about. I know that what we're doing from this question of key drivers is a massively parallel lasso regression effectively against the data where there's a couple of things that have to take place here, right? So we have to look into each dimension, and we have to look into those dimensions and do feature enumeration across all those dimensions. So how do you get from 24 columns to billions of possible combinations? There's a lot of logic that has to go into exploding your data into all of its groups, the subgroups and sub-subgroups, right? So there's a ton going on there. And then you have to do a massively parallel correlative analysis against all of those groups versus change in metric. Right? And so we do that. And the magic, part of it is the magic of what we're doing there, which is some of that's a little proprietary, but what's really exciting about Sisu is how you can do so much of it so quickly, all in parallel to come up with the answers this quickly. And that's the speed. Speed is a dumb thing to go to market on, really, because somebody's going to get faster. But the reality is you need speed for 2 reasons. You need speed because people ask questions quickly, and they want answers quickly so they can ask the next question quickly. And if it takes an hour, you just broke somebody's train of thought, and it's awful. And the other reason is you need to be able to identify what's going on and identify courses of action and take action at a rate faster than that action is changing your business. Because if you're lagging behind, you never catch up to the business change in a meaningful way. And so speed really is important, and those are sort of the key points that we're going through. The other thing that is super key about that is is calling these algorithms via API can be really powerful as well. So you can kick off that analysis, you can cause it to run, and you can pull the data that it generates out into the tool of your choice to operationalize. And so you can use that algorithm in new and novel ways that make sense for your business. It's not trapped in our tool or stuck behind our UI in any way. Yeah? So let's start with the first one because I'm not sure I understand it. So I think what we're talking about is the definition of the metrics themselves, like revenue or something. Or are you talking about the findings here down the side of these top drives?
Loyalty status, et cetera, the dimensions. You use the word dimension, driver, facts, I think. Those things.
Yeah, so those are actually defined in the data itself. So the part of what the algorithm does is it would look down a column called promo, and it would see that there is a promotion in a cell in that column somewhere called fall 25. And so what this is doing is it's looking at everything in the promo column that says fall 25, and those rows are what contribute to 0.42% increase in churn. So we are enumerating but not defining those subpopulations in the data which are driving metric change, and we call those facts or drivers. Does that make sense?
I guess my question is, how does Sisu know what the relevant set of columns are?
So we look across all the columns that you load into Sisu. So we will look across a pretty wide data set to do that. And what we find our customers doing in some cases, which is pretty smart, is loading in a small number of rows, but many columns, and seeing which columns have the greatest relevance, and then going narrower in the data set, narrow in the data set, but deeper in the data, many more rows, to find out the specifics inside those columns. So there's some question there as to how wide you go and how deep you go, and it really depends on what you're trying to solve. That's something we can help with as you go through defining how big a data set you need. We find, in general, as few as 25 dimensions can get you a lot of really interesting insights. Hundreds of thousands, a few million rows can get you a lot of interesting insights, and at least let you know what data sets you want to start working in and start analyzing. So, excellent question, thank you. The second one was, what if the data is in a bunch of different data stores? So there's a couple of things here. We need two things to go. We need a big wide table, and we need a defined metric. That big wide table can be defined via SQL inside Sisu, and we will perform a join from your Lakehouse to build the big wide table, and we will import it. If you already have a big wide table in your Lakehouse, just tell us where it is. We're more than happy to just grab it. If you have it defined through some type of a semantic layer, we could pull it in from wherever you're storing or materializing a big wide table. So you can define it and bring it in Sisu. You can materialize it somewhere else and point us at it, whatever makes the most sense for you. We don't want you to do any additional work than you have to, but you certainly can just do effectively a big old join inside Sisu to pull the data out. And then the other thing we need is a metric definition. Again, you can define it inside Sisu, or you can define it like in DBT, and we'll pull in the metric definition. Does that answer your question? Cool, thank you. Excellent question, yes?
So I guess I'm most familiar with data robots. So
again, thank you, excellent question. One which I may not be the right person to answer. So the algorithms here were originally built as part of Dawn Lab at Stanford by a bunch of very smart people working with Facebook and Google data. Our founder, CEO, is a brilliant man who knows everything about those underlying algorithms and is sitting 3 seats in front of you. And so he can turn his head at any moment and answer that at a depth which I am incapable of doing. So we've got 2 minutes left in this session before they kick me off stage. My recommendation is you talk a little bit to him. We also have on our website, we have how we get to the facts, which helps enumerate all that stuff in a document, which might be easier than me coming up here as your product marketing person and doing my best guess. So I want to answer that, but I want to answer it offline, and mostly I want to make our founder CEO answer that for me. Last question, because we really literally have 2 minutes left here. All right, thank you. Our booth is number 409. Please come and visit us. We would like to see you. If you asked a question, our head of marketing would love to give you something nice in exchange for your question. Just go down there and claim you asked a question, even if you didn't, and she won't know the difference. So just come by and get something good. Thank you again for coming. We appreciate it. Enjoy the party, which starts in 5 minutes ago. So thank you so much, and we'll see you downstairs.